Sir, pole changing,
Right. Pole changing,
stator voltage change control,
and other could be the stator voltage control. Right.
supply frequency control,
Very good. Supply frequency control.
eddy
और
current
let
supply.
me नहीं नहीं अब मैं किसी और को दूंगा चांस. किसने भी दिया ये जवाब? Although we have also mentioned the seventh one as eddy current control, right? Eddy current control. These are the methods which we can use for the for controlling the speed of the induction motor, right? We already have discussed about the pole changing method, uh, and this method, by this method we can have a multi-speed drive, right, or multi-speed motor. And now we know a difference between multi-speed motor and a variable speed motor. Yes or no? We know the difference or not? Do you know difference between the multi-speed and the variable speed drive? How
Yes,
many
sir.
of you know this? Raise your hand. Let me see. How many of people know this fact that what are multi-speed drive and what is variable speed drive? Only two people knows this. My goodness. Huh? Rudendru, you don't know the difference between a multi-speed drive and a variable speed drive?
Yes, sir.
You know?
Yes, sir.
बता सकते हैं क्लास को हिंदी या इंग्लिश जैसे भी मन हो.
सर मल्टी स्पीड में सर हमारा जो पोल होगा इवन नंबर होगा तो उसमें हमारा स्पीड जो होगा फिक्स होता है, उसमें वेरी नहीं हो सकता है.
ये तो कोई बात नहीं बोली तुमने. अब ये सारा तो मेथड स्पीड वेरिएशन का ही है. और कोई बताएगा भाई? कौन बताना चाहेगा? रेज योर हैंड्स. राहुल मीना को देते हैं, मैं मौका दूंगा. राहुल.
सर वेरिएबल स्पीड मल्टी स्पीड में कुछ फिक्स स्पीड्स होती है, वो उन पे वेरी कर सकती है मोटर बस, और वेरिएबल स्पीड में वो किसी भी स्पीड पे मतलब चेंज हो सकती है, चल सकती है.
Very good, very good. Basically multi speed means discrete speeds, right? We can obtain the some limited number of speed profiles from there, right? But with the variable speeds we can attain or we can have a any speed between certain range, right? Suppose अगर किसी मोटर की स्पीड रेंज 0 से 1500 आरपीएम है, तो विद द वेरिएबल स्पीड मोटर ड्राइव we can have any of the speed. Even it could be 300, it could be 400, 500, 600, or even 650 also, right? But with the multi-speed motors, we can only have the fixed number of discrete speeds. Means if it is being made for 500, 1000 and 1500, then only we can have these three speeds from that motor, right? So this is the difference between the variable speed and multi-speed motor drive, right? So one of the method is pole changing method. We already have discussed. And what is the basic of this? The basic is your synchronous speed is inversely proportional to the number of poles, right? So if we can be able to vary this pole, we will be able to vary the ns, right? And if this ns can be varied, the speed of your induction motor can also be varied, right? Because there is a tendency of this motor that it never crosses this synchronous speed. अगर ये synchronous speed कम कर देंगे तो वो खुद ही पीछे हट जाएगा. इस तरह से है, right? Is this fine?
Yes, sir.
Okay. We also have discussed about the stator voltage control, and we have studied that your torque is directly proportional to the voltage square, whereas current is proportional to the voltage, right? And because of this, what happens when we reduce the voltage to reduce the speed of the motor? What happens? Torque also reduces. That's why this method is only suitable for those applications where the torque demand decreases with the speed, right? And one of the way is to use AC voltage controllers before being feeding the supply to the induction motor, right? Then hopefully we have started discussing the supply frequency control, right? How this method is being used? Simple funda, which that your ns, again what we want to vary is the ns, as we know that this ns is proportional to the frequency. What will happen? your motor will go into the saturation, right? This we have learned or not? Have we discussed about the supply frequency control? Yes or no?
Yes, sir.
Right. So the funda was key, because we know that your EMF or V by F is basically proportional to phi, or phi is proportional to the ratio of V by F. So what happens is कि when we reduces the frequency, to reduce this synchronous speed, we had to reduce the frequency. This is very much clear to us, right? Now what happens when we reduces this frequency to reduce the speed? What happens? This phi get increased, right? But what happens कि beyond the rated value, beyond the, or that means कि to increase the ns, we have to increase the frequency, right? And to decrease this, we have to decrease the frequency, right? So when we decreases the frequency without altering this voltage, your phi, that what happens, that makes this motor to go into the saturation. And because of this, magnetizing current increases, core loss increases, humming sound is being there, right? So there are many drawbacks that come into the picture because of the this phi that get your motor into the saturation region. That's why what we do is, while decreasing the frequency, we also decreases the voltage, right? And we call that as variable voltage, variable frequency, as we are also varying the voltage along with the frequency, right? And that we do when your motor operates beyond the base speed, right? Beyond the rated speed. So during the rated speed or within the rated speed range, 0 to rated speed, what happens? We vary the voltage along with the variation in the frequency, right? After that, we doesn't vary this voltage. We keep this voltage to be constant, as we cannot apply the voltage greater than the rated value, right? So this we already have discussed the about this supply frequency control. Let us discuss about one other method, that is the rotor resistance control. Rotor resistance control, right? I guess you all remember that we have derived the expression for the maximum torque and the slip at which the maximum torque occurs, right? First, let us have a look for a motor which have this characteristic for the torque and the speed, right? This is the ns speed and this is zero speed, right? On this axis we have torque, right? We already have learned this motor have maximum torque at a certain corresponding certain speed, right? Corresponding to this speed, there will be a slip, and we call it as slip m sm, that at which your maximum torque occurs, right? This is tm. So we already have learned that if your motor which possess this characteristic, if we add on some resistance to rotor side, so this characteristic shift like this way, like this way. And what is the basis of this? We already have learned that what happens when we add on some resistance to it, right? Let it as R2 and this is at R1, right? When R2 is greater than R1, so this characteristic shifts to this side, this way, right? Now, what is being shifted? Basically, the point at which the maximum torque is occurring, the slip at which maximum torque is occurring, it gets increased with the increase in rotor resistance. That means the maximum torque that motor will deliver, it will now deliver at lower speed, right? And it is because of the rotor resistance, higher rotor resistance value. We already have discussed about the expressions for the maximum torque and the slip at which maximum torque occurs, right? We know this fact that the maximum torque of this motor, right? Maximum torque of this motor which possesses this characteristic is not going to change with the increment in the rotor resistance. Maximum torque is not going to change, right? Whatever was the maximum torque earlier, it will be there. It will be same when we add on the rotor resistance, right? But the speed or slip at which it will occur, it is going to be changed, right? So the concept, this behavior of your motor, induction motor, is being used for the speed control also. It can also be used for the speed control, right? Because we know that by varying the rotor resistance, we can vary even the starting torque. This is the starting torque for the first case, R1, this with the R2, and this with the R3, right? So you can see that higher the rotor resistance, higher will be the starting torque, right? Also, higher the rotor resistance, lower will be the speed at which your maximum torque is going to occur, right? So keeping this into your mind, this method is also being used to control the speed. But it is very obvious, we have studied that your induction motors are of two types, right? In case of first one, that is the squirrel cage, we don't have any option to add on the resistance, right? To increase the resistance, right? But with the slip ring type motors, we can add on some resistance through the slip ring assembly. So this method is applicable, right? This method is applicable only to which one?
The wound rotor.
Wound rotor or slip ring induction motor, right? Or slip ring induction motor. I guess it is very clear to the class, right? Now, see, conventional, there are the conventional way. How can we add on the resistance? By inserting the resistance to the slip rings, we can do this. But there are some advanced methods also, and that are called as static rotor resistance control. In the conventional way, we can directly add on some rheostat to the rotor side. But to have a better or efficient system, because if we directly add the resistance, what is going to be happen is we are going to waste the current or power in the resistance. But more effective way is the static rotor resistance control. Static rotor resistance control. Now, how does it being different from the conventional method, right? Let us see. What happens in this case is, suppose these are the three lines feeding the wound rotor slip ring induction motor, right? And this is the stator. So what happens is we can connect the stator, we can feed the stator of this motor through these three phase lines. So no doubt on this, right? But as it's a wound rotor or slip ring induction motor, three connections are also being available to connect the some external circuit. So instead of directly connecting the rotor resistance, what we do in this static rotor resistance control method is we take this, right, and we use our uncontrolled rectifier. What we do? We use uncontrolled rectifier such that the power, whatever the power is being there, right, on the rotor side, it get converted into the DC, right? With the help of this, it get converted into DC. Now to basically to have the control over this power flow, right? To have the control over this power that is we are sucking from the rotor circuit, right? Because whatever will be the rotor current, it is going to be passed through these circuit also, right? So what is being proposed is to use our resistance to connect the resistance through this, right? And to control the effective value of this resistance, one control switch is being connected in parallel to this, right? So what happens is the value of this resistance depends upon the opening and closing of this switch. So can you tell me what will happen if this closes switch? If this switch is closed, what will be the effective value of this? What will be the value for this circuit? This will be equals to, बोलिए, अगर ये स्विच क्लोज होगा तो व्हाट विल बी द वैल्यू? वैल्यू विल बी इक्वल्स टू, अगर ये स्विच क्लोज है तो, अरे बोलिए जल्दी, am I audible to the class?
Yes, sir.
शॉर्ट सर्किट हो जाएगा.
ये शॉर्ट हो जाएगा तो आर की वैल्यू 0 हो जाएगी ना. the current,
yes
whatever
sir,
will
R
be
की
the
वैल्यू
current,
0 हो जाएगी.
right, R की value 0 हो जाएगी क्योंकि whatever is the current, if I take this to be ID, so now ID will not go through this resistance R. If we short circuit this, if we close this switch, what will happen? The path for this current will be like this, right? This will be the path, right? These three will get short circuited. Is this fine? But once it will be open, it will be equals to R. So what is being proposed is, so by, it is being proposed that by closing or by controlling the switch, opening and closing, we can have a control over this, over the effective value of this R, right? So they have said that if we see this RAB, if it is A and B, and let the resistance connected between these two is RAB, effective resistance, right? Let the average value, the average value of resistance between A and B, right? Between the terminals A and B, let it be RAB. So RAB will be how much? It will be 1 minus del into R, where del is the duty cycle, where del is the duty cycle for the switch, okay? Where del will be T on divided by T, or T on plus T off, right? So D will be the duty cycle for this switch. So will this be the RAB? Yes, this will be the
Yes,
RAB,
sir.
net value for the resistance, right? Also, it is being mentioned that we take this current to be IR, that is flowing in the rotor circuit, and this current to be ID, which flows through the resistance. So they have a relation that your IR will be equals to root 2 by 3 of ID, right? They have this relationship. Now we have just learned that RAB is equals to 1 minus del of R. What about the power that will be consumed between this, between in the RAB? How much will be the power? Power consumed, power consumed will be consumed, power consumed by RAB will be how much it will be? It will be, let it be PAB, and it will be equals to I D square into RAB. Yes or no? Yes or no?
Yes, sir.
Can we write it as ID square into 1 minus del over R? 1 minus del into R? Because RAB is nothing but it is 1 minus del into R. We just have learned.
Yes, sir.
Now power, can we calculate the power consumed in per phase, in single phase? It's a 3-phase power, na, total power. So can we have a consumed power for per phase by each phase, or you can say that for each phase how much it will be? It will be equals to PAB by 3. अगर 3 से पावर इतनी है तो हर एक फेज से कितनी होगी, क्योंकि ये 3-phase मशीन है, तो इट विल बी PAB by 3. So can we write it as equals to ID square into 1 minus del into R over 3? Yes or no? This will be the power, right? And we can also replace this ID in terms of IR, as we just have noted that this ID and IR have they have relationship. So your power consumed for each phase, right, that becomes equals to 1 by 2 into R into 1 minus del into IR square. I guess this it is being clear to you, right? Is this fine? Is this fine?
Yes, sir.
Now let us have this scheme is basically an open loop scheme. To make this, we can have a closed loop version of this also. We can have a closed loop version of this scheme also, that is a static rotor resistance control. So let us see how can we make this scheme a closed loop one, right? So closed loop speed control speed control with static rotor resistance control, right? Static rotor resistance control. कैसा होगा? सबके सब बना के देखो अपनी नोटबुक में खुद से, नहीं तो मैं बना ही रहा हूं यहाँ पर, आप एक बार देख सकते हैं। एक बार माइंड में जरूर विजुलाइज करें कैसा होगा। वी हैव अ वाउंड रोटर और स्लिप रिंग इंडक्शन मोटर जिसके स्टेटर को सप्लाई करने के लिए वी हैव दिस 3-phase लाइन, राइट? Of course, we will connect this to the circuit. Now it's a static rotor resistance control. So what we do in this is if we use a one uncontrolled rectifier. We use one uncontrolled rectifier to rectify the output such that it can be fed to some resistance, right? So this is the basic scheme. Just we have seen, right? This is the one. Right, this is R, and there is a one switch. This could be any of the controllable switch, right? Now to make this as a closed loop system, what is being suggested is that we want to make it a closed loop. So what we'll do, first we'll measure the speed, right? So this will be the actual speed, right? This actual speed will be passed on to the comparator, basically to the control unit where there will be a comparator, right? And comparator will compare this actual unit with the reference speed, right? After the comparison, the error or the difference between the two, the desired value and the actual speed, will be generated as error, the difference, and that will be passed on to the speed controller. Right? One of the way is to use the information or to allow this controller to control the duty cycle for this switch, right? But to make it more robust, it is being suggested that another loop is being added, that is the current control loop, right? So the information is being used to generate the value of the current that should be there, right, flowing in the circuit. And what we do, we again sense that current and we compare it with the reference value of the current. Whatever is the difference, accordingly the current controller takes on the decision, right? And it drives basically the duty cycle. Basically it gives this decision to generate the duty cycle, and they are writing it as base drive basically, and that will be a duty cycle generator, right? Duty cycle generator, and that basically controls the D for this switch, right? I guess you could have understood the drive. Have you got an idea? बताइए जल्दी, yes or no?
Yes, sir.
इसमें किसी को कुछ पूछना हो पूछ सकता है. You please get solved one numerical on this topic, and it's the example 6.17 of the book GK Dubey, right, which I referred to you to learn this course, right? And you please solve that. Even I can help you if you solve it in the later on classes. Let us discuss the last method for the speed control, and that is the slip power recovery. Slip power recovery method. The method is almost like a rotor resistance control, right? And this method is also being applicable, right? This method is also being applicable to wound rotor or slip ring induction motor, right? Applicable to slip ring or wound rotor induction motor. Right? In this, what is being proposed is, okay, suppose if we take the equivalent circuit of the induction motor, if we consider the equivalent circuit of the induction motor, definitely it will have a stator side winding and the rotor side winding, and winding means combination of R and L, right? So this will be the equivalent circuit, right? Where this will be the stator side resistance and reactance, and these are the rotor side reactance and resistance, right? Okay, this will be the rotor side EMF induced EMF, let it be S time of E if E is the induced EMF on this side. We are considering the turns ratio to be unity, right? That's why E, they are same, just there will be a scaling factor of slip. Turns ratio equals to 1. Turns ratio between the two stator and the rotor windings, right? If this is the case, what happens? अगर ये एक स्क्विरल केस टाइप होती तो we could have short circuited this, but we are considering the slip ring type motor, right? So in the slip ring motor, we know that we don't short circuit the armature windings, right? We take it out for the connection to the external world. So let us suppose we have connected an source voltage, right? We are instead of some resistor to the slip ring connections, right? The situation is we have connected a source VR instead of connecting the resistance, external resistance R, right? Have you understood the thing? क्या कर रहे हैं हम जो स्लिप रिंग है वहां पर सोर्स वोल्टेज एक ऐड कर रहे, ना कि कोई resistor. See, we have learned that your PM, the mechanical power of the induction motor, it is basically PG minus PCU. We have learned this. अगर ये वोल्टेज सोर्स ना हो, अगर मैं इसको शॉर्ट सर्किट मान लूं, तो योर जो मैकेनिकल पावर डेवलप होगी रोटर सर्किट में, it will be equals to the air gap power minus the losses, right? We already have learned that we don't consider the core losses on the rotor side if it is being running near to the synchronous speed, right? We already have discussed this fact. So that is being already excluded, core losses. But if we consider the copper losses, the mechanical power that your motor develops, it will be equals to PG minus PCU. Now further, if we neglect the copper losses, right? If we neglect copper losses, your PM will be equals to PG, right? But what will happen if we add on some source to this side? What will happen? Suppose this source, because of this source, some power PR is being either added, right, or being absorbed because of this source, right? So PM will be equals to PG minus of PR, where PR is acting just like your PCU, right? PR is the power absorbed by the source, right? If PR is the power absorbed by the source, right? This source can absorb the power or can deliver the power. It will depend upon the phase of this voltage, right? Phase and magnitude of this voltage. So it is being proposed that by have a control over this PR, where PR is the power delivered by the source, we can have a control over this PM. How? Suppose PR is 0. When PR is 0, then PM will be equals to PG, and your motor will run at a rated speed, right? Motor will run at it's a natural speed, right? But when this PR is equals to PG, if your PR, the power that is being fed through this voltage source, it becomes equals to PG. So your what will happen to PM? It will become 0. right? So that means if your PR is 0, then your speed of the motor will be your natural speed, that will be natural rated speed NR. But when your PR becomes equals to PG, your speed will be 0, right? So it implies that by controlling the PR, we can have a control over the speed of this induction motor, right? Is this fine?
Fine.
Is this fine? Right. But we can also, it's not only like this, this can only act as a sink. This can also act as a source, right? I mean to say that the power, the sign of this power PR, it can also be controlled, right? This PR can also be negative, this PR can also be positive, right? One, this PR will be negative, this total will be the sum, this expression will become PG minus of PR, that means PG plus of PR, right? Then it will start supporting this mechanical power, and at that time the sum becomes even greater than the mechanical power. So because of that, your rotor speed even will be higher than the rated speed. So when the sign of this PR will be negative, the speed of your motor will be higher than the rated speed or the synchronous speed, right? When PR will be negative, right? So let me write this for you. When PR is negative, speed of the motor will be higher than the synchronous speed, right? And when this PR is positive, जो हमने केस पहले पढ़ा, and when PR is positive, what will happen? Speed will be less than the synchronous speed, right? Speed of the motor will be less than the synchronous speed, right? So by controlling this PR, we can have a control not even in the subsynchronous range, but even in super synchronous range, right? So by this method, we can have a speed above and below the rated speed also, right? Now in this method, right, these methods of speed control, right, they can be classified. These method, right, right, into how many methods classified as slip power recoveries into slip power recovery schemes, right? Slip power recovery schemes, right? And two such schemes are,
सर आपकी स्क्रीन अटक गई है.
स्क्रीन फ्रीज हो गई.
यस सर.
दिख रही है अभी? नहीं.
यस सर अब ठीक है.
अच्छा ठीक है, मोबाइल नेटवर्क से है, हो सकता है थोड़ी दिक्कत हो. तो कहने का मतलब यह है कि स्लिप पावर रिकवरी स्कीम जो है, उनमें से दो ऐसी स्कीम या स्लिप पावर रिकवरी की स्कीम जो है, वो है स्टैटिक शेयर बस, ना, सर बीएस भी कहते हैं, सर बीएस ड्राइव, and other is static Kramer drive. These are the two which drives, and which principle these two drive works. They works on the principle of slip power recovery. Is this fine?
Yes sir.
Now what happens with this static shear bus and the static Kramer's drive is there is a slight difference between the two. Very slight. In both of the cases, we try to recover the slip power, right? And the method is applicable to the wound rotor machine. So suppose this is the three-phase line through which we feed the induction motor stator, like this way. Suppose we are feeding the stator of this induction motor through these lines, right? Now, in the case of rotor circuit, what we do on the rotor side, we use again the similar way, we use one rectifier circuit to rectify the power, that rotor power, right? Rotor power in this fashion, right? So now what we do in this case is, in case of slip power recovery, instead of wasting it in the rotor resistance, in some resistance, right? What we do, we again convert the energy through the inverter, into AC, right? What we do, we convert this energy which is on the rotor side into the AC supply with the help of inverter circuit, right? And now with the help of this inverter, even we can have the control over this power flow, and that again we feed accordingly. What we do, we use and we feed this to the three-phase line from which we are feeding this induction motor, right? We feed it back, we feed this back, right, to the lines, and we do it with the help of one transformer we use in between the two to isolate it from the supply, right? This is the transformer basically, right? So this is basically static shear bus drive. We call it as static shear bus drive, right? The voltage which will be developed here will be VD1, and they are marking it as VD2 over here. Of course, there will be no difference between the VD1 and VT2 if this inductor is fully charged, or if the current flowing is ID, will be, right? At that time, ID will be almost zero. And even in the neglecting the stator drop, your VD1 plus VD2, that will be equals to 0, right? We are not going to read this much in detail, but I guess you could have got an idea about the static shear bus drive. How does it work, right? Now, similar to this static shear bus drive, there is a static Kramer drive. Static Kramer drive. It is also a kind of slip power recovery scheme. It also uses the slip power recovery scheme. And what we do in this case is, again, the method is applicable only to wound rotor machine, right? Let us take that this, we are having three-phase lines to feed the three-phase motor, and we are connecting the stator of the motor to these three-phase lines in this fashion, right? Okay. Now what happens to the rotor circuit is, what we do, instead of directly connecting the resistance, again we use one uncontrolled rectifier such that the power can be converted into the DC power, right? Just like we did it with the static shear bus, right? Again we use the same funda, but what happens is, whatever will be the difference between the two is, instead of feeding this energy back to the supply, what we do in this case is, we use one motor, we use one DC motor, right? We use DC motor to feed this, or to feed this, to feed through this supply, right? Now, to control the speed of this motor, we control this field flux, we control the voltage, right? Because of this field flux control, the speed of this motor get changed. But the objective is not to control the speed of this motor, it is to control the speed of this motor. So that's why in this scheme, these two are being mechanically coupled with each other. They are being mechanically coupled, right? They are mechanically coupled. Now, because of the variation in this motor of this speed, the speed of this motor also get varied. And we call it as static Kramer drive. This is static Kramer drive, right? So these are the methods which we use for speed control of induction motors, right? And that is all about the course of your induction motor drive that is being there in the unit 3rd, right? So unit 3rd is being complete from my side. If you have any queries, you can ask to me. And from now onwards, we'll be going for unit 4, that is dedicated to the synchronous motor drive along with the BLDC motor drive, right? So we will be discussing on these two from the next classes, right? Although I want to make it clear to you that your 90% of the syllabus is being covered and the coming 2 units only possess the 10%, right?
Okay, sir.
You should, in fact, it will be better for you to read the first 3 units very deeply. And I will be really happy if you perform good even in the in the questions which are being from the first 3 units, right? Although I will be teaching the unit 4 and 5th also, but it's means I will be happy if you perform better even in the first 3 units, right? उससे बहुत सारी चीजें क्लियर हो जाएंगी और अच्छा भी रहेगा आगे के लिए, ठीक है?